So good afternoon, everyone. I hope you enjoyed your lunch, and I'm very happy that you managed to find the room which is hidden in the back rooms of the conference. So this is very exciting that you managed to get here. So this session is about the EOSC AAI implementation, where myself, my colleagues, we want to give you an update of where we stand in regards to the EOSC AAI, what is happening right now, both in terms of implementation, but also in terms of designing what will be coming next. So my name is Chris Kanelopoulos. I work for Zeant, and I wear multiple hats. So here, with one side, with my hat as co-chair of the EOSC AAI task force in the context of the EOSC Association, along with my colleague Yana, who is the other co-chair. And in the context of the EOSC Future Implementation Project, where we do implement the EOSC AAI, there I am responsible for leading the EOSC AAI task, and there I'm working also with my colleagues Slavek and Nicholas, who are also members of the task force. So what we want to talk to you about today, and perhaps have a discussion also, and try to get also some feedback, is really about where we are with the EOSC AAI. And because I have seen a number of new faces in the conference, and of course it's been a number of years which we didn't manage to see each other, I thought that it makes sense also to provide some introduction, trying not to go too much back in the past, but at least to give a bit of a context, so that what we discussed today do not just appear as falling from the sky, but they're grounded to the previous work that has been happening. Then we are going to talk a bit more focused on exactly what we have done on the implementation level and where we are today. And then we're going to get a glimpse of the work that we're doing right now in setting the stage for the upcoming work, which is basically the work that we do within the EOSC AAI task force for the upcoming developments. But everything, I think, will come together through the presentation. So, I don't know how many of you are aware about a report that was published in the very beginning of 2021 by the EOSC Architecture Working Group at the time, which did have a task there to develop an initial design for the EOSC AAI architecture. And many of us that are already now in the new EOSC AAI task force were also members of that initiative also. And that task force produced a report which is available on the site of the European Commission, which basically provided the context and gave us the guidelines of what we need to do on the implementation phase in order to meet the requirements for the European Open Science Cloud. In the next few slides, I will try to very briefly go through the key areas of that report, basically trying to explain to you what was that was identified as gaps that need to be filled in during the next 2 years, effectively from 2021 until today, and try to walk you through these requirements. So, first, let's start with something very important, and with the SRIA document, which I think all of you should be familiar with it by now. And there, the AI has a very prominent place. And in the document, it's clearly defined that the purpose of the AI, of the authentication authorization infrastructure in EOSC, is to support the FAIR principle for data services, but also take into account the requirement for high-trust collaborations that need to be established and maintained with very low friction. And this is part of this document, and this is also one of our guidelines of what we need to be implementing in order to develop the EOSC AAI. When we started the work in that task force, and this is included in that report, we tried to set out a few very, very basic, high-level principles that we would use as our lighthouse, so that we can make sure that we always follow some generic guidelines whenever we are having very technical discussions, always going back to the roots, trying to see what is that we want to achieve. And these 3 guidelines were, first of all, that the user experience is the first measure of success. It doesn't make sense to develop something complex that is not usable by the end users. This doesn't mean anything. all trust within the research collaborations flows from the communities. Why we build the EOSC? We build the EOSC so that we can enable collaborations, we can enable research to happen, and research doesn't happen in isolation. So the communities, the research community, is a key ingredient for the EOSC, and it's where the trust mostly comes from. Researchers are part of communities, are part of projects, initiatives, and as such, they do need to be able to access services, resources, data to be able to fulfill their research requirements. And last but not least, when we're talking about the EOSC, we are talking about a distributed system. A system of systems. You have heard about this in the context of what EOSC is. And as such, there is no center in such a system, and that's something that we really have to take into account and always remind ourselves that we are using and developing a distributed system. In order to further facilitate our work, we extended these first principles, and again, these are described and analyzed in the report I shared a few minutes ago. And those were saying basically that the EOSC is based and is focused on multilateral interactions and multilateral trust. What does this mean? This means that we have many parties, many entities coming together, many different research communities, many different infrastructure providers, many different service providers coming together, and we need to establish trust in a multilateral manner. Establishing bilateral trust, saying, I, Christos, trust Slavek, and then Slavek trust Nicholas, and Nicholas has trust me, doesn't scale to the extent that we need to have it scaling at the EOSC level. So we need to establish, to provide an EOSC that would allow us, all of us, to establish trust in a multilateral manner without having to have these bilateral discussions again and again and again. Another very important aspect that also stems from the aspect of that we are operating in a distributed system is that the EOSC model should honor the autonomy and the integrity of all members. And what this means? This means that effectively we cannot design solutions, we cannot design an EOSC where we consider that there might be unbounded trust. I mentioned about the communities, I mentioned about infrastructure providing services, and there are always trust between them, but the trust has specific barriers. We will be going from one administrative domain to another. Trust has to be established, and we cannot design solutions that would expect that this trust is not required and that there is a full trust across all the systems. In addition to that, and something very important, is that the EOSC should enable the flow of attributes that either describe the person or the capabilities, capacities of the person within a given collaboration in order to be able to access content, services, and resources. And last but not least, the EOSC should be user-centric in the sense that users will not just authorize once and forever access to their personal data, but users should be able to give scoped and time-bounded permission for transfer of their personal information. So when we started working on the EOSC, we recognized that there was a lot of work that had happened before that time. So even going back to 2011, 2010, with the first initiatives like FIM4R trying to see how federated authentication could be used within the research collaboration space, and then with the AARC project, developing a solution of using federated access for research collaboration. These were massive initiatives that brought together many infrastructures, and they produced very viable results. As such, one very key aspect for us is that we are not going to reinvent the wheel with the EOSC, but rather build on top of the outcomes that we have already achieved through previous initiatives. And one of these is the AARC blueprint architecture with all of its extensions, its guidelines, and the governance that is happening within the AEGIS group, which means the AARC engagement group for infrastructures, to provide the starting point for what we call the EOSC. And in addition to that, and something very important, the AARC blueprint architecture and EOSC allows also to become global. Although we're talking about the EOSC AAI, which is the European Open Science Cloud AI, we do recognize that research is international. Research does not know geographical or continental boundaries. We know that scientists will have to collaborate with other scientists in Asia, Africa, Americas, and we need to be able to enable this kind of collaboration. Building on top of AARC, which is a truly global initiative, allows us to have interoperability at an international level beyond the boundaries of Europe. So our starting point when we started the work with the task force back in end of 2019, it was a time that the AARC community had developed the AARC Blueprint Architecture version 2019, which introduced the concept of the AARC Blueprint Architecture plus the context of the community AIs and the infrastructure proxies, and you will hear more about these things in a few moments from my colleague Nicholas. So that was the current developments at the time, and through the EOSC project was implementing an initial version of the EOSC AI, we managed to prove and to and demonstrate that it was possible to use the AARC blueprint architecture as a model to not only establish trust, but also to allow access from users of multiple infrastructures to resources provided by other infrastructure providers. And the situation at the time, effectively, was looking like we had 4 major infrastructures coming together. One was EGI with the EGI check-in service. The other one was Xeant with the Xeant Edutim service, EUDAT with the B2 Access service, and Indigo YAM. And trying to establish this multilateral trust between them in order to be able to enable users from one infrastructure to be able to access services provided by another infrastructure. Technically, this was proven to work. We were able actually to prove in real life, in production environments, that implementing the AARC blueprint architecture, the guidelines, could allow us to enable to create an EOSC AI that was usable by the end users. Having said this, though, one of the shortcomings of that time was that the trust that we were building between all of these infrastructures was happening on a peer-to-peer basis. Effectively, we were kind of cheating, and we're saying we do establish multilateral trust, but in the end, it had to be Xeant Edu teams connecting directly to EU.B2 Access, to EGI check-in, to Indigo YAM, and then repeating this process. Indigo YAM would have to connect to Edu teams, to EGI check-in, to B2 Access, etc., etc. For infrastructure, that's fine. But if the number of infrastructure providers increases, if the number of communities increases, then suddenly managing this trust in this way is very, very difficult, to the point that it becomes impossible to scale. This is why, within the work that we did in the task force and the work that is described in that report, we came up with the notion of the EOSC AI Federation. So what is the EOSC Federation? What it brings on the table? Effectively, instead of having to go through this peer-to-peer trust establishment between all entities, what we're doing with the EOSC Federation, we allow entities, communities, infrastructures, service providers to join the EOSC Federation that has specific requirements for technical interoperability, for policy interoperability. And by joining the EOSC Federation, effectively, you make a statement that you are at a certain trust level because you meet the requirements to be part of the federation. From that point onwards, any other infrastructure, any other community that joins the EOSC AI will immediately be able to trust everybody else without having to go and negotiate on a peer-to-peer manner with all the others this interoperability. By the fact that you are a member of the federation, this means that already you meet specific technical and policy requirements. So the AI Federation brings one of the missing points that we had up to this time, the aspect of scalability, of being able to scale the EOSC AI to the levels that we require for a truly inclusive European open science cloud. In addition to that, we do recognize that the EOSC AI cannot operate in isolation. Researchers, and I just realized that there is one image upon the other, but I will walk you through this. Sorry for this. Researchers do want to use their home institutions to log in. They want to use the account that they have at the home institution and to be able to access services that are provided through their collaboration, to access services that are provided through a project that they're part of, etc., etc., etc. So already we have the EDUGAIN interfederation connecting all the national federations together. And it was only natural for us to say that the EOSC AI Federation will have to be part of this ecosystem, will have to be part of the EDUGAIN interfederation and be able to benefit from the peering of trust between all the federations together. So that in a seamless way, and without having again to re-establish trust, services, infrastructures can authenticate users through their community AIs or directly through the institutions using the EDUGAIN interfederation service. In addition to that, by being part of the EDUGAIN interfederation, also we achieve another goal in terms of scalability. Because I have been mentioning the infrastructure proxy, I have been mentioning the community AI, and you will hear more details about what these are from Nicholas. But one key aspect about scaling the EOSC AI to the levels that we want to scale it is how are we going to deal with the national infrastructures and with the services that are going to be flourishing from all these infrastructures that are going to be built across Europe. And clearly, it doesn't make sense to have everybody come and have to join one EOSC AI Federation when they already have the structures in their countries from the national federations that they can go and join directly. So by having this interfederation concept and by having the EOSC AI Federation be part of EDUGAIN, what we can enable is also scalability of the registration and the trust enablement of services across the various countries where national federations exist. And this is basically all the countries in Europe and the majority of the countries across the world. So this is what it was described more or less in very few words in this report. The report, I think it's more than 100 pages. If you would like to have a reading, I think it's a very nice reading and will give you a lot of insight of what we are doing exactly with more technical details. But this report has been our roadmap for what we wanted to implement in the EOS Future project. So the implementation we're doing basically was to take the current state of affairs in beginning of 2021 and develop the missing aspects, the missing bits that were identified by the report for the EOSC AI. So in EOS Future, now I'm changing my hat and I wear my EOS Future hat. In EOS Future, we're focusing on the implementation aspects of the EOSC AI based on the report that was published by the European Commission through the task force that I mentioned before. In parallel to this activity, there is a new task force that has been set up right now under the EOSC Association, which is focusing on the requirements and further evolution of the EOSC AI. So as we are working right now in EOS Future to implement what the previous report has been telling us that is missing, now there is another group that is looking ahead and is saying, okay, we are now implementing this, what else is missing? What do we hear from the research infrastructures that they need to be able to do and they cannot do today or they will not be able to do with the implementation that we're doing right now? What also we hear and we listen from the implementation project itself? Because there is feedback when you try to implement something. And now that group is looking at how the EOSC AI should further evolve after we finish these implementations. So in the EOS Future project, in order to be able to cater for the implementations that need to happen, effectively we split the work in two areas. One area was focusing on EOS core and the requirements that stem for the EOSC AAI. And this is what we call the micro level. EOS core is about the EOS core services, what we need to create, to develop in order to enable the EOS core services to be able to authenticate users through the EOSC AAI. So our focus there is very targeted towards the EOS core services. The second area of work, in parallel to the first one, has to do with the macro level. And this is really about implementing the EOSC AAI and working with the infrastructures for cross-infrastructure access. This is where the EOSC Federation lives. This is where effectively we try to see what we need to do in order to be able this cross-cutting AI that will enable all the infrastructures, all the communities to be able to be part of this ecosystem and to be able to use the AI in a seamless way. So a little bit about the work that we've been doing in the EOS core. So the EOS core proxy was already operational when we started the EOS Future project, but at the time it was basically serving the EOS portal. What we set out to do was, first of all, try to set some rules regarding the operation of the EOS core proxy. First and foremost, what are the services and what are the requirements for these services in order to be able to connect as EOS core services to the EOS core proxy. And there are a number of technical requirements, a number of policy requirements, and also by working together with the security team within EOS Future, effectively, we are also applying the EOS security baseline as a set of requirements for an EOS core service to be eligible to connect to the EOS core infrastructure proxy and through that to the EOSC AAI. In addition to that, we prepared documentation for all the developers of the EOS core services in order to understand exactly what is that they can be expecting from the EOS core infrastructure proxy. What is the attribute profile, what are the capabilities, but also provide them with integration guides of what they need to be doing in order to take the fullest advantage of what the EOS core infrastructure proxy has to offer to the EOS core services. And already by now, we see a number of EOS core services that as they are being developed, they are already getting connected to our test infrastructure and they are able to test and utilize the capabilities of the AI. And then as they go to production, they are already ready to be able to utilize the EOSC AI and provide seamless access to those services. In the second area, in the area of the EOSC Federation, this is where actually we have put most of our effort. This was the biggest challenge. And there, basically, when we started the work back in mid-2021, effectively, we set a few tasks, a few goals that we wanted to achieve in order to better understand where we were at the time. One aspect was to benchmark the AI readiness of the science clusters. So we are talking about the EOSC Federation, which means bringing together the research infrastructures, bringing together the infrastructures, bringing together the science clusters that are comprised by the research infrastructures. But up to that point, we had never done a thorough analysis of what is the status on each of these infrastructures. What is the maturity level? Some of them are further ahead, some of them were just starting to implementing their solutions. But that part was missing, so it was a blind spot that we needed to cover. In addition to that, one of our major drivers in EOS Future has been and still is the science project that have been identified as the key activities in EOS Future that will showcase the capabilities of EOSC. And through the science project, we had to understand what are the requirements, what are the use cases, what will the scientists that they want to do cross-domain science need to be able to do and what the AI needs to be able to offer to them. And getting this information would allow us to, first of all, update our technical requirements, even perhaps in some cases update our policy requirements to make sure that what they need to be able to achieve is feasible, and feed back this information back to the EOSC AI task force, which is focusing really on designing the next version of the EOSC AI. In addition to that, and after getting in touch with the science clusters, we wanted to create a plan based on which we can make sure that all science clusters and infrastructures will be onboarded on the EOSC Federation in time in order to be able to achieve the goals of the project. So the goal was that the first implementation of the EOSC Federation was that the initial cluster research infrastructures and infrastructure proxies from the infrastructures were connected and allow the seamless access of users from these clusters to the services provided within the context of EOSC Future. And with this, I would like to pass the microphone now to my colleague Slavek, who will talk to you about the analysis that we did on the AI readiness of the science clusters. And Slavek, please. Yeah.
Thank you, Christos. So I will start to explaining our goal within this activity. And we want to engage and identify and engage with the key parties to make sure that everyone important is really on board on this EOSC AI and they are technically ready to be connected and there are no obstacles there. And we want to make sure that they understand the principles of the EOSC AI and they are ready on technical and also on the organization level to be integrated within the EOSC AI. But I have to say the implementation of EOSC AI is rather an ongoing process, because to be part of the EOSC AI, you have to follow up some standards, and Nicholas will explain these standards later in the detail. But these standards are constantly evolving, because we are still kind of in the beginning of this activity, and there will be more need for specific types of collaboration, and to be able to do that, we have to be still compatible with each other. So even the standards that we are using are constantly evolving. Our goal is also to provide consultancy. If someone doesn't understand a particular detail or have a technical problem, the EOSC Future and our activity is there to help them understand, or somehow even guide them to a technical solution that they can use to integrate. And also help to overcome any obstacles in a way. Again, it might be organization, it might be misunderstanding of some standards, or even having trouble to grasp the whole concept of the EOSC AI. So we're trying to help there as well. And at the end, we are also gathering feedback from all these communities that we are working with and use it for the further evolution of the EOSC AI. So the key parties, as Christos already mentioned, are for sure European e-infrastructures, which are very important in this part, but also mostly EOSC science clusters, because the science clusters sometimes doesn't have direct relation to all these activities. They are not part of the standardization, at least not in all cases. So we try to make sure they actually understand it and they are able to connect. And we also focusing on the EOSC science project that Christos already described for the exact same reason. And the science projects are sometimes involved in the more science clusters, so there is a different approach into this. But even though this is the parties that we are trying to actively engage with and actually ask them and monitor their progress, we are completely open to any other communities project and so on who wants to connect to the EOSC AI, and we are ready to provide help. So the status in general is that AI is really recognized as an important activity. Almost everyone, or even completely everyone, know that this is something that need to solve. Also internally, to be able to manage their own users and their own services, but actually also to connect to something like EOSC AI to get interoperability with the rest of the world. And we have kind of this chicken egg situation, especially for the science clusters, because they are not sure what they should focus on. If it's like focus on their users and allow them access to all the services within the EOSC AI Federation, or start with providing services first for other users from other science clusters, and then help own users to take services from other science clusters, for example. But this is not really a problem. The individual science cluster perceive this is a thing that it exists, but they understand they have to do both at the same time, and eventually it will just start fitting together very well. With a situation with European e-infrastructures and some research infrastructure is really easy, because especially the e-infrastructures are directly engaged in the AI activities. So following the standards and connecting to the EOSC AI comes really naturally for them. So there is almost no work we need to do. So we're mostly focusing on the science clusters and science projects. And also what is really great news, we have this general agreement on standards, because the AARC standards was there way before, and there is a lot of participants, and this is something that is generally agreed on to be used everywhere, and nobody wants to use anything else. So this also makes our life a lot easier. So if I focus now on the science cluster, which was our main goal now, to understand what they are doing, what is the status there. And the good news, for most of them, there is like a single AI solution available. Not for all of them, some of them prefer to have more like a distributed approach, but they are building a single point which will even integrate this distributed solution and make for them easier to connect to the EOSC AAI. It's also easier for us, because if we need to work with 5 science clusters, it's easier to manage and to provide them all the help they need than if we need to focus on the individual research infrastructures. So this is a great thing for us, that they are really integrated in the science cluster and working together on the AAI level. It's not perfect, it's not always there, but at least in the all science clusters, they are getting to this point. There will be a single point of contact which will be integrated with the EOSC AAI. Also, which is really great news, that all users from all science clusters have access to AAI in some extent. Most of them are using their home institution to sign in, but some of them doesn't have this option. But always within the science clusters, there is an option for them, either to use some social accounts or have locally created accounts. But at the end, the AAI is there for all the users, and we haven't identified a single group without access to the AAI. The slight problem is that some users might not be aware that this option exists. So they don't know where to sign in to have an account for the AAI, which will be integrated in the EOSC AAI. But I think as this will get traction and the users will be informed about this option to interoperate with other services within the EOSC, they also get the information where to start. So we don't perceive this as really a problem. And as Christos already mentioned, all of this is based on the AARC blueprint architecture as a main standard that is widely accepted, and every science cluster is ready to follow this architecture. And also the AEGIS interoperability guidelines, which was selected as a thing that needs to be supported to be really interoperable within the EOSC. And so in the science cluster level, this is widely accepted and everyone wants to do this eventually. But as I was mentioning, this is something ongoing, because the standards are evolving and there is quite a lot of standards that should be supported from the beginning. So it's not always there at the moment, but everybody, all science clusters are working hardly on working on that to really implement it. So to sum it up, we are in a really good place. We are involved. We are in touch with all the science clusters, and we are monitoring the progress, trying to help them, and the progress is really there and is getting better and better each month. So this is something I consider a big success. And for the next stage, we want to focus more on the science project. So this is the end of my part, and I will pass the word back to Christos.
Thank you, Slavek. And just to be a bit also more specific now, effectively, at the moment, we have managed to set up and create and have a technical operational EOSC Federation, and start to get also experience of what this means, how this changes things in enabling and providing trust through a federated manner. So this is a new thing within the context of EOSC. This is something that we had not done before and we are now introducing. Although we have a lot of experience by doing this at the national level, as I mentioned, it's a new thing in this context. So I try to avoid technical terms, but in the next part of the presentation, we will have to dive a little bit deeper on the technical aspects. So I will start with a few technical aspects also here. The way we know today how to do federation for the authentication authorization infrastructures is using the SAML protocol. And we have the tools to do that. We have the specifications of how we can do that. So the first instantiation of the EOSC Federation is based on the SAML protocol, but that is only for the inter-federation aspects and the intra-federation. Between the proxies within the infrastructures, services can still be able to use whatever protocol they prefer, like OpenID Connect or Auth2, but what is expected is that across infrastructures, across communities, we have to use SAML as the protocol for federating everything together. We know and we're following the developments for OpenID Connect Federation, which is a new specification that is currently in draft. You will hear more about this from Nicholas, but this is not there yet. So we have to build things around SAML. Having said this, we already identified from the science projects a number of use cases that we cannot solve with the existing tooling. So it is, for example, it is impossible to be able to implement complex workflows but which are very common within the scientific community, such as, for example, a researcher from a community X requiring to get compute resources in one infrastructure, perform the computations there, and expecting that when the computation finishes, that the results, the data sets will be able to push automatically to another infrastructure that's providing data services. And how this automatic trust and automatic access control is happening, this is something that we cannot deliver with the SAML protocol. We know how to do that with OpenID Connect, but we don't know how to do OpenID Connect across infrastructures. So this is one of the topics that we identified as a problem. So, oops, now we have an issue. I mean, we have this thing that it works, but it cannot cater for all the use cases. So this is one of the items that we pushed back to the EOSC AAI task force and said, look, this is a problem, and this is something that we need to solve urgently because we have the use cases right now. So today, to come back to the EOSC Federation, we have already connected the majority of the cluster research infrastructures. Escape is connected with Escape YAM. EOSC Life is connected with the Life Science AI. Panos and Expanse are connected with the Umbrella ID. From the SOC cluster, we have CESDA AI connected, and Daria will be connected very soon, and then we'll be working with Clarin. From the infrastructures, we have EGI with the EGI checking service. We have EUDAT with EUDAT B2 access. We have the Xeant SP proxy and Xeant Edu Teams. And of course, we have the infrastructure proxy for the EOS core services. All of them connected together and trusting each other. So the next steps now is really to see how we can take a step forward, how we can enable more complex use cases. And I would like to invite Nicholas to come and talk about the work that we're doing now in the context of the EOSC AAI task force to fill in these missing gaps. And actually, while we're doing this work, let me highlight that, at the same time, many of the infrastructures that are implementing AIs are trying the new development, the new draft developments of the architecture in their development environments to be able to see how this is coming together. So we have design from one time and real-time implementation on the other in order to be able to speed things up in the best possible way. Nicholas, please.
Thank you, Christoph. So this part will be about the evolution of the EOSC AAI architecture. We'd like to start with the starting point for the EOSC AAI. So it is based on the AARC blueprint architecture, already mentioned by Christos and Slavek. This architecture allows users to use different authentication sources, for example, academic identities from the EduGain global network of institutional organizations. There's also support for social media using different protocols like OpenID Connect and SAML. And through this proxy-based architecture, the user can access services that can again speak different protocols like SAML and OpenID Connect. So this architecture enables the translation between different protocols. At the same time, it is very important to highlight the role of the blue vertical layer that you can see on the leftmost diagram in this of the architecture that includes the components that are responsible for enriching the identity that comes from the user's home organization with the attributes that are managed in the context of a collaboration and that are typically responsible for determining the resources that the user will be able to access. Another interesting view of this architecture is what you see in the middle, that shows also the community AI and the infrastructure proxy layers. So the purpose of the community AI is to streamline the access of the researcher to services, both that are part of the community AI, but also those that are provided by other infrastructures. And then we have the infrastructure proxy layer, which allows infrastructures that have many services to provide a single gateway for the services. And this gateway is responsible for centralizing all the relevant policies and business logic. And to make this more clear, you can see this in where we have highlighted a very typical use case, where we have users from one community. In this picture, you can see PANOSC. So they can use their umbrella ID to access services that are, of course, part of PANOSC, but also they can access services that are offered by Escape through the infrastructure proxy of Escape, and at the same time they can access EOS Core services that are behind the EOS Core infrastructure proxy. And similarly, users from the Escape community can access, of course, their own services, the services that are behind the PANOSC infrastructure proxy, and again, the EOS Core services behind the EOS Core infrastructure proxy. So I think this gives you a good idea of how this logical separation of the community AI and the infrastructure proxy layer works. Now, the EOSC AI is not just complying with this proxy-based architecture. It also means complying with a set of interoperability guidelines. You can see here, for example, guidelines that provide, that standardize the expression of group information, which is typically used for authorization. There are guidelines for how to express assurance information, so how you can trust the assertions about a user. How to express resource capabilities, which are again a very useful tool for authorization. How to provide hints about which identity provider to redirect the user. So all these guidelines are important to enable interoperability because these different AI services. Now, for the evolution of the EOSC AI, we have identified 5 different areas. First of all, having a consistent user experience and interfaces for service providers, enabling support for multi-infrastructure workflows, providing scalable trust establishment mechanisms, the growth of EOS beyond the research and education community, and the community attribution authorization. So, starting from the consistent user experience and interfaces for service providers. What is the problem here? So, users typically will need to go through multiple identity provider discovery steps in this multi-proxy architecture. A typical example is, of course, a user that starts by selecting their community AI, then they get redirected to the community AI, and then they need to choose the identity provider of their home organization. It is very important to highlight that in this process doesn't mean that users will have to re-log in again, provide username and passwords, right? I mean, the user doesn't have to log in multiple times, but still, this multi-step identity provider selection process can be frustrating for users. So, with the guidelines that I mentioned earlier, we already have some ways how to improve this identity provider discovery process. For example, there is a specification that allows a service to send a user to a specific identity provider. Example use case, you know that this service is offered for a specific community. The service can send the user directly to the community that they need to log in from. Another hinting mechanism allows the service to send the user to a specific discovery service. Again, if the service knows the community for which the user may need to come from, they can use this discovery service hint. And lastly, there are also hints that allows to customize the identity provider discovery screen so that it shows information about the service that would again guide the user through the IDP selection process. Similarly, another aspect of improving the user experience is the adoption of the AARC community-based access category. This entity category is very important because, again, it can be used during the discovery process to distinguish between the community AIs and the authenticating IDPs. So the AI services that act as community AIs versus the identity providers that are from the home organization of the user. The entity category can also be used by services that know that they only need community-based information, and for those services, this entity category can be used to filter out the authenticating IDPs, so they can show directly to the user that you need to come from a community AI. And conversely, for services that don't rely on community information, they can still make use of this entity category to only include the authenticating IDPs and hide, for example, the community AIs, if this fits the requirements of the service. And lastly, with this accent category, we have also identified a bundle of attributes that build the user's community identity. So, with this entity category in place, the identity provider can choose exactly the attributes that are needed for community-based access. The other area that I mentioned earlier and also mentioned by Christos is the multi-infrastructure workflows. So, as already mentioned, with the current EOSC AAI, it works without any issues when the user is consuming services directly. But we have a lot of use cases that there is a service agent that acts on behalf of the user to consume services and resources on another infrastructure. Of course, if the services are behind the same infrastructure, then again there is no issue. But the problem starts when the resources, when the agent and the service that need to be and the resources that need to be accessed are in different infrastructures. The typical way that these workflows work is based on OAuth2 token validation, because these scenarios are usually based on token-based access. With the existing standards, however, rely on direct trust relationship between the protected resources and the authorization server that issues the tokens. In the example here, you can see that there is a community service on one infrastructure that needs to access resources behind another generic infrastructure service here that is on a different infrastructure. Let's call this infrastructure B. So the problem that we need to solve is how this service here can determine if the token is valid or not.